In this video, we're going to go over x and y intercepts and how you find them both from a factored form polynomial like we have here. So in this example, you can see all the factors. Each one of these factors, these parentheses, contains within it some information that's very important to us. And what that information is the zeros of the equation, or in other words, the x-intercepts. So if I say, let's set this parentheses equal to 0. Let's say x minus 1 equals 0. And we solve that little equation, and we get x equals 1. So what's important about x minus 1, or x equals 1? Well, imagine substituting 1 in right here. What's going to happen? This whole parentheses is 0, right? Because it becomes 1 minus 1. Now, if this parentheses is 0, and this parentheses over here is, I don't know, but it's not 0, and this one's not 0 either. They're numbers like 4 or 5 or 2. What happens when you do 0 times something that's not 0? You still get 0. So you can multiply 0 by all these not 0 things, and the overall result of the whole equation is that it becomes 0. So, in other words, f when x equals 1 equals 0. And the reason that's important is because if you have some function here, and let's pretend it looked like that. It doesn't, but let's just pretend. And let's say, oh, here's our x equals 1 right there. You see that's a 0 of the function. It crosses the x-axis there. And by looking at all these other factors, like this one over here and this one over here, we can find the other places where this function is 0. So let's do that. If we solve the equation negative 2x plus 3 equals 0, we get 3 equals 2x, which leads us to 3 halves equals x. Okay, that's another 0 of the equation. And 2x plus 4 equals 0. That means 2x equals negative 4, which means x equals negative 2. So we found another 0. And don't be confused by the word 0. It doesn't mean that x is actually equal to 0. The x location is usually not 0. But it's called a 0 because that's where the function itself becomes 0. It's a little confusing. I prefer calling them x-intercepts because that tells you what's actually going on. Now, it also goes backwards. Let's say we have some function, and this is going to be totally unrelated to the equation above. Let's say it just looks like, I don't know, this. And you've got it touching the x-axis here and touching the x-axis over here. Well, if you know where it's hitting the x-axis, like let's say that's negative 2 and this is positive 3 over here, what that tells you is your function, I'm not going to call this f, let's call this g of x. Your function is going to look something like this, x plus 2 and x minus 3. That corresponds to those two x-intercepts that you can see here. And there might be some other stuff going on, right? It might be, you might have a factor of 1/2 in front, you might have some exponents in here. We'll talk about how to find those exponents later. But for right now, what I want you to focus on is the relationship between these factors right here and the x-intercepts they correspond to. That's the important part of all this. Now, that's x-intercepts. We haven't mentioned anything about the y-intercept. So let's just go over that quickly. If I have a function, f of x equals, you know what, let's just grab this function up here. This is a perfectly nice function. I'm going to grab this guy. We're going to solve this thing and figure out where its y-intercept is, okay? So, to figure out a y-intercept, it's very easy. If you think about a y-intercept, remember, it's just a point like this. Well, what's x equal to at the y-intercept? I don't know what y is, but I know x equals 0. So, just figure out what f is if x equals 0. You say 1/2, 0 minus 1 cubed, negative 2 times 0 plus 3, and 2 times 0 plus 4. Okay, well this becomes simple very fast. You have negative 1 cubed times 3 times 4, which, if you go through the math, gives you negative 6. Okay, so that is how you find a y-intercept. And if you remember, this is also called the constant of a function. The constant is the trailing term at the very end, the one with no x's on it, which you find simply by multiplying together all the numbers that don't have x's in the equation. Don't forget their exponents, and don't forget the number out in front.